There's a lot of things you're going to ask and I won't respond to. All right. So, full disclosure. I told you these proofs are a little easier. Okay. But I will say 5-2 is our stepping stone. It's not like how we're really going to be doing proofs. Now, listen carefully. I need you guys to listen. We're going to prove triangles are congruent 5 ways. They're called shortcuts. SSS, SAS, ASA, AAS, and HL. You don't even know what those mean yet. We're going to find out today. The first one. Are you ready? We're going to learn the first one today. So good news. Those are all what I call stop signs. If you can get to one of those 5 shortcuts, you have proven that 2 triangles are exactly the same. Okay? 3 parts. SAS, a pair of sides, another pair of sides, and the angles between those 2 pairs of sides. Okay, SAS. We're going to learn that today. But would you agree, if we really wanted to do it the long way, how many sets of information are there between those 2 triangles? Sets. 3 sets of sides and 3 sets of angles. So guess what? Before we know any shortcuts, if we're going to prove a pair of triangles are congruent, there's going to be at least 6 pairs of information. Not at least. There's going to be 6 pairs of information. What I was going to say is how many steps there's going to be in the proofs. If you were to break them all up into separate steps, there'd be at least 6 steps in the proof, right? But at least you know when you're done. How do you know when you're done? 3 sets of sides, 3 sets of angles. Do you agree with that? And then we'll talk about shortcuts. Yes? All right. So this is in your 5-2 notes. All right. Now here's what I do not like about this book. They mark the stuff on the picture already for you. Okay. And you're like, well, that's kind of nice. Kind of, but not really. Because I think it's good to mark it as you say it, or else you're gonna forget to say it in the proof because it's already marked. Did you follow that? I'm afraid you're going to say it in the proof because it's already marked in the picture. Do you agree you have to say it in the proof for it to count? Yes? Okay. So AD congruent to CB. Let's keep going. So I'm going to mark it AD CB. Ooh, I'm already noticing these triangles are not just reflective. They're kind of twisted too, aren't they? Do you agree? All right, let's keep going. Let's keep going with sets of sides. DC congruent to BA. DC, BA. That's 2 sets of sides. And I'm going to stop there because those givens have to do with the sides. The other ones looks like they're to do with angles. So I'm going to say given. Some of you are going to like to do this. I'm going to help you out. To keep things straight, I'm going to put a little S and circle it, and put another little S and circle it to kind of remind us we have 2 sets of sides so far in our proof. You don't have to do that. That's just to help you so far. Okay? Or you could up here, and again, these are not the kind of proofs we're going to be doing, so I don't want to spend too long on this, and I don't want to get too deep into it. But you could put 3 S's and 3 A's up top and cross them off as you go. I don't know. We're really not going to be doing this many steps in a proof very often. All right, because we're going to learn shortcuts today. All right. Next, could we have listed these on the same line as givens? Yeah, but they're angles. So let's list them on a new line. ACD congruent to CAB. ACD. Does everybody see that it's that angle right there, the blue one I just marked? Are you okay with remembering how to name angles with 3 letters? It's like you're literally tracing it out with your pencil. Okay, if you don't know how to do that, that was chapter 1. You have to review. This is honors. We have to assume you remember that. If you forget it, come talk to me individually. If you forget. If you do not know how to name an angle with 3 letters, you're going to be in a lot of trouble this chapter. Okay? Do you agree I cannot just call that angle angle C? There's 3 angles at angle C. I don't know which one you're talking about. You have to say ACD. That traces out that one. Okay. Congruent to CAB. This double one. And on your quizzes, I'm not going to pre-mark them on the picture for you. I actually think it's worse when they do that, right? So you're going to have to mark those on the picture as you go. Well, guess what we just marked? A pair of angles. I'll put a little A and circle it. Next, angle C. What's up, Olivia? You good? Another pair of A's. Given. And they get a single arc mark. Well, we really don't have much left, do we? What's left? A pair of sides and a pair of angles. Okay, now we're out of givens. Let's look to the picture. Step 3. Side AC. Side AC is congruent to, and yes, I'm going to be picky. Paige. Yeah.
In the given it says, triangles.
Yep. Yeah, common mistake. And I'm going to finish your question because this comes up every year, okay? She's saying we're trying to prove these triangles are congruent, but didn't they just say ACD is congruent to CAB, right? Let's talk about one pair of angles. This is talking about the whole triangles physically being congruent to each other, right? Okay? All right. AC, ready? AC in this triangle, triangle 1, is congruent to CA. Good job. Good job. CA in the other triangle. Now you have to come up with a reason. That was not given. You have to come up with a reason. Reflexive property. Good. Reflexive property. You're going to use that one a ton. So if you're a student that likes to keep things organized and kind of have little go-tos like word banks or like proof banks, whatever you want to call it. Remember when we did that on the board? If you want to have a page, and maybe you still have that one page dedicated to proofs. If you want to add a new line and say triangle congruence proof packs, you're going to see reflexive property a ton. You're going to see the reflexive property a ton. All right, that would be one to add to your little bank. All right, well, that's another pair of sides. Guess what we're done with? Sides. We've done 3 sets of sides. We're done with sides. All right, well, there's only one pair of angles left. Can I say angle D is congruent to angle B, or do I need to use 3 letters? You could say CDA. If you say angle CDA, congruent to angle, what would you have to say in this triangle? CBA. Careful. In triangle 1, you started at the angle with the double arc mark. In triangle 2, you have to start at the angle with the double arc mark. See it? What's that one called? ABC. If I were a student sitting in your seat right now, I would say, Mr. Westphal, why at this angle did you name it with 3 letters in line number, where was I? In line number 2, you named it with 3 letters, but then in line number 4, you named the other angles with 1 letter because there's no confusion. I can't say angle C down here because there's 3 angles there. I can say angle D is congruent to angle B because there's only 1 angle at each vertex. Do you see it? And I'm okay with that. I think it's easier that way. Why are angles D and B congruent? It's got to be something new. We don't have a given. Paige, what do you think? Good job. The third angles theorem. And we just barely touched on this on Friday. Do you remember the third angles theorem? Here was the third angles theorem. If 2 angles in one triangle are congruent to 2 angles in another triangle, then the third angles have to be congruent. There's no other way around it. Do you agree? There's only 180 degrees in a triangle. If you have 2 congruent to 2, the third angles have no choice but to be the same. Tell me.
So it's like transitive property for triangles?
Which one?
The third angles theorem?
It's not. Not really. Yeah, I'm trying to see if you could even use the which way are you thinking the transitive property?
Because never mind. I think I thought of it wrong.
Yeah, I think I know what you're saying. You're saying if this is congruent to this and this is congruent to this, then those have to be. But
that's not right.
Yeah, not quite. It's a good try. Trying to apply that. Are we done? Well, that was our last set of A's. I don't think anybody would disagree with you right now that those triangles are congruent, right? I mean, we proved all three sets of sides, all three sets of angles. They're the same size because of the sides. Size because of the sides. They're the same shape because of the angles. So, step 5, triangle, blah, 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 is congruent to triangle, blah, blah, blah. Now, I'll give you a hint. This is called a congruence statement. Steal their order. Triangle ACD. ACD. Congruent to triangle CAB. Now, you don't know what to put there. I'll tell you for this one proof. This is the only proof we're doing like this. Then we get into shortcuts. That's just the definition of congruent triangles. What's the definition to congruent triangles? They have all three sets of sides congruent, all three sets of angles congruent. It's just the definition of two congruent triangles. Now, while I'm on the topic of the congruence statement, if you get confused during a proof, all eyes up here for just a second. If you get confused during a proof and you don't know how to name this angle right here, this angle right there, you're like, I don't know how to name that angle. Steal the congruence statement. For example, if I want to call it DCA, I said the letter D first. I said the letter C second. I said the letter A third. Do you agree with that? That tells you, even if you get confused by, oh, is it flipped? Is it not flipped? I can't tell. That tells you the order to do in triangle 2. Ready? I'm going to say the letter B first. I'm going to say the letter A second. I'm going to say the letter C third. That gives me the corresponding order. Does that make sense? We use the congruence statement. Even though we haven't proved the triangle's congruent yet, if that's where we're going to end up, that's the right order too. So let's use it. All right. That was 5-2. Now into shortcuts. A little something called SAS. Side, angle, side congruence. Again, we're going to have 5 by the time we're done. This is number 1 of 5. We're not going to learn any others today. Just SAS. So that's good news. You know exactly how you're going to finish the proof. You're going to finish the proof with, oh, these triangles are congruent by reason? SAS. If I were you, I would be looking at that picture and thinking, is that really enough information to say those triangles are congruent? Just 2 pairs of sides and the angle between them?
Yeah.
What do you think?
No, because the other 2 don't have to.
Here's my analogy. I don't have a ton. I wish we had more time to talk about this. But here's my analogy. I give you a red straw and a red straw. And these 2 red straws are exactly the same length. I give you a blue straw and another blue, nope, not that one. And another blue straw, and those straws are exactly the same length. And then I give you an angle that those 2 straws have to be connected at. 40 degrees, 20 degrees, I don't know. Whatever the angle is, they're the same in both situations, okay? Now, let's say I give Elizabeth these 2, the blue straw, red straw, and the angle. And I say, connect these And then I'm going to give you one more straw. You're going to have to cut it to make it a triangle. But I'm going to do the same with Anthony, okay? The question is, could they come up with different triangles with the red straw, blue straw, and angle? And then some random straw they have to cut the length. Could they come up with different triangles? So let's bring this down here. Let's bring this down here. Whoop, that's not going to work. Just ignore that. You know, and maybe they try to like rotate it and stuff, but wait a minute. The angle has to stay that. So their only choice is to draw the angle, to draw the two sides and the angle that goes together. Do you agree that's their only choice right there? To connect the red straw, blue straw with that angle is that combination right there. And then what do they have to do with their third straw? Do they have to cut the length? They have to measure the distance from here to here and cut it to that length. Because guess what? If you make these two straws a certain length and the angle has to stay between them, they can't pivot at all because of the angle. Are you with me? So that forces these two triangles to be congruent because those third sides are not congruent. And even though I didn't say anything about these two angles or this side, it has to match up with these two angles and this side in that triangle. There's no other way to do it. We call this SAS congruence. Side, angle, side. Is it important where the angle is in the triangle? SAS. It has to be the angle between what? The two sides that you're given, the straws that you're given. Has to be the angle where they come together. Do you all hear that? Because we're gonna learn SAS, ASA, AAS, and they're different combinations. You have to be able to keep them straight. All right. So the book walks us through. Don't write this down. It walks us through the combination of how do you confirm two figures are congruent. Do you guys remember on the last quiz? Are these two figures congruent? Oh yeah, I could do a rotation and then a reflection, and they get mapped onto each other. Therefore, they are congruent. Remember that? The book argues that if you can do a combination of rigid motions and map one onto the other, then they have to be congruent. So in SAS, that's what they walk us through. They say, oh, are these two triangles congruent? Well, let's translate it so A and D are together, and then rotate it to line those up, and then reflect it. And I think that's a little bit too much. Like, I don't think we need that. I think we would agree those two triangles are congruent because two pairs of sides and their included angles match up. Great news for you. We're going to do a proof, and you know where we're going with this. What's our last step going to be? Triangle, blah, 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 is congruent to triangle, blah, 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 by SAS. Okay? You know where you're going to go with it. Now, we have to think back to the things we used to use in proofs all the time. Do you remember what they were? Definitions, givens. That reflexive property we saw is going to be used a lot. What about when two lines are parallel? What about when two lines are parallel and there's a transversal going through them? This should jump off the page at you. When you're, from now on, when you're told two lines are parallel and you have two triangles, you're going to use, not that one, alternate interior. Question for you. Yeah, so the four were alternate interior angles, alternate exterior, corresponding, and consecutive interior. Do you remember those four? You have to remember those four, okay? Now, I have good news for you again. I told you these proofs are going to get easy, okay? Just trust me, please. Don't glare at me. All right. Let's cancel some of these out. We had four: alternate interior, alternate exterior, same side, consecutive interior, and corresponding. Ready? Back when we did parallel lines and a transversal, those were all four possibilities for us, right? But now we're not dealing with that. We're dealing with triangles. So guess what's erased? That's erased because we're going to make this triangle. or these two triangles, right? That gets erased. And then what gets connected? That, right? Oops, not like that. That gets connected. And let's see. That gets connected. That gets erased. That gets erased. That gets erased. That gets erased. Okay. So where were our parallel sides? Well, it was this one and this one. Do I know these two are parallel? Ooh. Are these two parallel? I don't know. I mean, this line could be drawn like that, and that line, it could be drawn like that. I don't know. They don't have to be parallel. If I'm not told, I can't assume. Do you agree? All right. Now let's narrow down which of those four theorems we're going to be using. Am I going to use alternate exterior? Why not? The transversal doesn't go on the exterior of those parallel lines, does it? The triangles only exist between. Do you agree? Okay, so again, am I going to use alternate exterior? No, they're not inside the triangles. Alternate exterior, out. All right? What about corresponding? Corresponding was like here and here. Oh, wait, corresponding. One of them was on the exterior, wasn't it? It's out. What about same side interior or consecutive interior? Ooh, wait a minute. Do you see that angle right there? This picture stops. It doesn't keep going out here, does it? Are you seeing it? Consecutive interior would be here and here. Do you agree? That's not going to work. That one of the consecutive interior angles, it has part of the angle in the triangle we're talking about, but not outside of it, right? So which one are we going to use? Alternate interior. Okay. When you see parallel lines in a proof, alternate interior angles are going to be congruent. Do you see them? Do you see the alternate interior angles I just labeled? Now, how do you know which pair of alternate interior are congruent? Because one of the pairs are attached to the parallel lines. The other pair are not. I draw a Z. Okay? I'm actually going to have you pause for 1 second and look up here. Do you see, if I trace the parallel lines and the transversal, do you see the Z that's made? It's the angles tucked inside of the Z if you trace over the parallel lines that are congruent. Do you see the other pair of lines, though, over here in blue? Are we told those are congruent or parallel? No. What if we trace the Z there? Are these alternate interior angles congruent? We don't know. They're not parallel. We're not told they're parallel, are we? Are those blue lines parallel? No. We don't know yet. Couldn't they have been drawn like this? I mean, it could have been drawn like that, correct? And they would not be congruent because those lines are not parallel. So you can only use the pair of parallel lines you're told when you're doing alternate interior. So I like to trace out, if you get confused, trace out the parallel lines and the transversal, and it makes either a Z or a backward Z, and then you can identify the alternate interior angles. Are you with me? All right, we're ready to start our proof. BC congruent to DA. Given. Tick mark, tick mark. Might as well put BC parallel to AD on the same line. And we mark parallel with arrows. We mark parallel with arrows. There's so much I want to tell you guys just to like help you, but I don't want to overwhelm you. All right? How are we feeling right now? Overwhelmed or okay? Somewhere in between?
Yeah.
Okay. Can I give you a warning? If you're told segments are parallel, does that mean congruent?
No.
Does it count as an S in SAS? Does parallel? And you should ask the question, well, can I have parallel lines that are not the same length? Yeah, right? So parallel lines does not count as an S in SAS. The only reason BC and DA counted as an S in SAS is because we were told they were congruent. So I'm going to put an S there because we have one S and we have good news. We don't need all 6 sets of information. We have a shortcut now. All right, we use the parallel lines. Now we're on our own. We got to start figuring out some stuff on our own. All right, make me proud. We haven't used the parallel lines yet, have we? We said it, but we haven't used the result of it. Who can name the angles with confidence that are congruent by alternate interior? I want to take a shot at it. Olivia?
Would it be D, A, C, and B, C, A?
So DAC, remember the center letter is the vertex. That's that angle. Is that the one you want to name?
Yeah.
DAC. I like it. Now, could she have said CAD? She said DAC. Could she have said CAD? Yes. But the order of the second angle depends on what she said in the first. So Olivia, since you said DAC, now you have to say,
B, C, A.
yeah, so as soon as she started with letter D, she had to start with letter B in the second one. B, C, A. Those are alternate interior angles. And that's a pair of A's. Well, I mean, you know where we're going with this. There's only one shortcut we've learned. Unless you want to do all 6 sets of information. You guys want to do all 6 sets of information? No. So we know what's left. What's left? S, right? Give me an S. Give me an A. S is the last one. We're out of givens. It must be something obvious to us in the picture itself. Page?
AC is congruent to CA.
AC congruent to CA by the reflexive property. Man, that's gonna pop up a lot. AC congruent to CA. And is that the other side when they're joined together makes for an included angle?
Mm-hmm.
Do we have SAS, or is the angle between the two sides we know are congruent to the others? Yeah, it's SAS. Reflexive property. Let's make a rule. I look at a proof. Ready? I come to a proof. I know I'm going to use the reflexive property when the triangles have a shared transversal, a shared side, right? A shared side. Do you agree? I'm going to use the reflexive property when my triangles have a shared side. Shared side. AC, CA. Shared. All right, I have an S, I have an A, and there's another pair of S's. Are we done? Just about. Are we ready to say the triangles are congruent? Yeah, triangle ABC. Congruent to triangle CDA. By SAS. SAS. That's not bad, is it? Be honest with me. Is that bad?
No.
Who said that? Is that Tessa?
No.
Try Tessa. Next. In the diagram, QS and RP pass through center M of the circle. What can you conclude about the triangles? Well, I think they want us to say they're congruent, but we can't say that unless we get to SAS. And don't make this into a proof. Okay, don't be a nerd. All right. Let's just walk through it and see if we can give reasons for our answers. All right. Here we go. Ready? QS and RP pass through the center M. What's MS called? In the context of this problem, a radius. Do you agree it's a radius?
Yeah.
Come on, goes from the center out to the edge. It's a radius. We know that, right? What's MP called? A radius. What's MQ called?
Radius.
What's MR called?
Radius.
They're all in the same circle. Aren't radii in the same circle all congruent? I mean, ooh, those two triangles are, at this point, they're not congruent. What do we have? What do we have so far? S. Hold on. Do we have SAS yet? No, right now we have S, two S's. We just have two S's. That's not one of them. That's not a shortcut we learned. Okay, well, it's kind of like our only trick right now is SAS, right? That's like the only thing we've learned. So it's going to be SAS if it's going to be congruent. And which angles have to be congruent? Tally?
SMR
Yep. And you could say any order in the second one, as long as you say I'm in the middle. SMR, QMP. Why are those angles congruent?
Vertical angles.
Vertical angles. Vertical angles. Ooh, do you remember vertical angles?
My best friend, vertical angles.
That's sad if it's your best friend. I'm just kidding. Vertical angles are always congruent. Vertical angles are always congruent. I will tell you this much. I taught this class for a long time. Reflexive property comes up a lot. Vertical angles come up a lot. You're going to see this in triangles quite a bit. You're going to see, prove these two triangles are congruent. And they're point to point, like an hourglass. Point to point, like an hourglass. Do those triangles have a reflexive property pair of sides shared? These two triangles right here. Can you use the reflexive property on these two triangles? You can? Reflexive property. SM congruent to SM? No. SM in this triangle? Wait. Is there an overlapping pair of sides between the two triangles? Overlapping. Overlapping? No. Are you going to use the reflexive property? No. Hourglass shape? Two lines intersecting to create vertical angles? Are you going to use the vertical angles, Darren? Yes. Look for it. I can't tell you that enough. Look for those two things in proofs. They're going to happen a ton. Vertical angles, reflexive property. Is class seriously almost over? Time flies when you're doing proofs. All right. I'm going to cut this down a little bit.
I thought it was fun.
All right, I guess it technically starts, well, it starts on 241. Yep. 5, 6. All right, I'm going to change this. I want you to do 5, 6. Now, here's what I'll say about number 6. There's 4 triangles in the picture. Make sure in your notebooks you redraw the picture and make the triangles bold that you want to actually prove congruent. There's only 2 of them you're proving congruent. There's 4 in the triangle, just the way it's drawn. 5, 6. Yep. 11. 19. Now here's what I'll say. Here's what I'll say. I need you. You cannot walk in tomorrow and give me a poor effort on 5 and 6. Okay, you have to try these. I bet you're gonna do pretty well, but if you struggle with them, it's okay. But I have to see attempts all the way through on both proofs. Got it? Awesome.
I mean, it can't be anything that we haven't gone over.
Here's your notes. I got the feeling that you should be. You should, because it's you.
I'm kidding.